In this video, I'm going to show you how to compute the derivative of an inverse function using the reciprocal formula. This way, we don't have to explicitly compute the inverse function, which is kind of hard to compute in this case. Our first step is going to be to swap x and y. So we initially have y equals x cubed minus 7x, and we swap x and y to get x equals y cubed minus 7y. Now, our next step is to take the derivative with respect to y. So we're differentiating with respect to y on both sides. And dx dy is our left-hand side. And that's equal to 3y squared minus 7. All right, and now our last step, step 3, is to say that dy dx is 1 over dx dy. So we just have to flip both the left and right hand side here. Dy dx is 1 over 3y squared minus 7. And there we go. That's the derivative of our inverse function. Now let's do a bit of a trickier question. So the process is still the same. We're going to start out by replacing f of x with y, and then we've got y equals ln x, and then we switch y and x to get x equals root ln y. All right, now we differentiate with respect to y on both sides. D over dy, both sides. And this side becomes dx over dy. The right side becomes, what is this? This is 1 over 2 root ln y times the derivative of natural log, which is 1 over y. So dx over dy equals 1 over 2y root ln y. And now we just have to flip both sides, dy over dx. We flip that fraction, we get 2y root ln y. And there we go. There's our derivative of the inverse function. For our final example, we'll do an even trickier function. The process, again, is still the same. Replace f of x with y. Y equals ex squared plus 4 sine x, and then switch x and y. Get x equals y squared plus 4 sine y. Now we take the derivative with respect to y of both sides, and we get dx dy equals itself times the derivative of the top, so that's 2y plus 4 cos y. And now for the finishing touch, we just gotta flip both sides. Dy dx equals 1 over all this stuff. 2y plus 4 cos y, and we're done. We've got it. There's our derivative of the inverse function. Using this reciprocal formula can save us lots of time when computing the derivatives of inverse functions, especially when it's hard to compute the inverse explicitly. In the future, we'll use this technique to find the derivative of inverse functions at particular points.